want to cover very quickly buoyant force. Now, if you imagine um, water inside of water, so this is the old argument, is water wet? So you imagine a, a, a volume of water inside the rest of the water. What holds it up? All right, you know, and so Archimedes worked this out a long time ago. That the force that's holding it up is the weight of the water that's displaced. Now, in this case, they're equal to each other, right? And so he worked out in general, like you put a ship in the water, the weight of the water that it displaces is what holds the ship up. So if a ship is less dense than water, it stays afloat. If a ship is more dense than water, then it sinks, right? And so we look at this and we go, okay, what does this mean in terms of how much of an object floats? So if you look at the average density of an object in a fluid divided by the density of the fluid, you get the fraction of it that's submerged, right? And so if the density of the ship on average, because the ship is actually mostly air, if the density of the ship on average is less than the density of water, then only part of it sinks, right? And for submarines to go underwater, they have to make themselves more dense than water. Think about that for a minute, right? Um, and then the density of water, if it's water, we also call this the specific gravity, right? The specific gravity of something is its relative density to that of water. Another quick note on water. Any of you that have been water skiing know that water, the surface of water is not soft when you're moving fast. Um, so there are a lot of forces that hold fluids together. And there's surface tension, there are adhesive forces, there are cohesive forces. And so these definitions, just there for your amusement. But these are the pieces of making the surface of water much harder when you hit it at speed. This is why you don't want to jump off a really high bridge. This is why for divers, we actually have a sprinkler spraying the area that they're going to be hitting the water to break up the surface tension of water and break up some of these forces so that when they hit the water, it doesn't hurt nearly as bad. All right, one more video and we'll be done with fluids.